Hello everyone, Andrew here, talking again about the Numerai data science tournament. And now we're approaching the end of our prototype phase. So hopefully you've had the chance to read about and play around with some regression machine learning algorithms. And now our goal is to actually implement these algorithms to predict the tournament data. And while building our model towards tournament prediction, we need training data to actually train our model, and we need some metrics to gauge how well our models will actually perform in the tournament. And fortunately, the Numerai Hedgefund has provided us with all these resources. So first, before we go into the metrics that our model will be assessed upon, I think it's a good idea to first have a more detailed look at our training data that is provided by Numerai, given the Numerai dataset that we downloaded from their official website. So this should give us a better idea of the task at hand and the scope of the task that we're trying to do. And so here I have opened in ParquetViewer the training data. And in the first column, we have era. Era is essentially the timestamp of when this row of data has been collected. And I believe in real life, one era stands for 1 week. So this is so era 0001 is just 1. And we go down. It's probably going to stay era 0001 because the ParquetViewer is going to save memory because my computer doesn't have the best specs in the world. So it only reads the first 1,000 rows out of 2.4 million rows. But the training data does include multiple different eras. In fact, I think several hundred of them. So these are data taken over multiple weeks. And then we have, for the columns, many different features. I believe also several hundred of them. And if we want to train our model on all of the features provided, we're going to run into some memory problems very soon, unless we have a data center grade server of some kind to do our training for us. But don't worry, the Numerai people has foreseen that this could be a potential problem, and they have provided us with the tools to deal with it. And I'll go into it in more details later. But after all these features that we could use to train our data, we finally arrive at the targets. And as I have mentioned in my previous video, that target NOMI 20 is that we're mainly attempting to predict. But you might ask, what are all these other targets doing here? Like target Jerome 20, target Jerome 60. What are all these targets doing here if you're only trying to predict target NOMI 20? Well, these targets are essentially different indicators of how a financial asset is doing that has varying degrees of relationship with target NOMI 20, which is the final target that we're trying to predict. So a good analogy of this is that maybe, for example, target NOMI 20, training for target NOMI 20 is like training for an SAT exam. And or the other targets could be specifically the math section or the reading section, or even more specifically, the trigonometry or calculus, for example. And training your model, training different components of your model to these different targets may benefit your final model as a whole in predicting target NOMI 20. So these other targets are essentially just other different components that have some sort of relationship with target NOMI 20. So feel free to explore them if you're building your when you're building your model. So then again, at the very end, we have IDs, which just represents the different financial assets that these rows of data are for. And yeah, so this is the training data. And of course, after the training data, we also have in the Numerai dataset the validation data. So basically, after training our model, the training dataset, use the validation dataset to make some predictions and see how accurate that prediction is. Basically, validation. And after we made our predictions, we're going to upload it to Numerai's website. That's how we did. So now let's talk about metrics. Essentially, how our model will be assessed by the Numerai hedge fund. So first, let's look at this file in the dataset called example validation prediction.csv. So the model that we build should take the validation set as an input and output something similar in structure to this file. So on the first column, we will have the ID of every single financial asset that our model was trained on. And then the second column will be a floating point number between 0 and 1, representing our prediction for target NOMI 20. Now, this example prediction was produced by a model developed by Numerai's internal research, which they have actually provided us. They have actually provided this model to us with their data set, but we'll go through that later. So to find out how a model actually does, all we have to do is to go to Numerai's official website and upload the CSV file. So here we go to diagnostic tools and upload prediction. And since we haven't run any of our own models yet, the only CSV we have is the example validation predictions. So we're gonna load it, and it's gonna take a while. So the purpose of the example prediction and the example model that Numerai has provided us with is really to give us a benchmark of the quality of the model that we are expected to create for the hedge fund. And when we create our own models, we will be comparing how it does, how our model does against the example prediction and the example model. So let's just wait for it to finish processing. So now Numerai has finished processing our the CSV file that we uploaded, and here we can see the metrics that it used to assess our models. So in general, the numbers that are colored green means that we have done an above average job for that particular metric, and numbers that are colored white means that we have done an about average job, and anything that's colored red means that we have done poorly, sort of below average. So here with their example predictions, nothing red, obviously, otherwise that would be quite embarrassing for them. And let's break down the metrics by column. On the first column, we have performance. So these are just measures of the correlation of our prediction with the actual recorded value of target NOMI 20. And if you hover your mouse over the different names of the metric, you will get a little one-sentence description of what these actually are. And similarly, if you hover your mouse over the numbers, you get your percentile score compared to all the other submissions. So this is basically performance. in general, we want these numbers to be as high as possible. The higher, the better. And this, for the second column, we have risk. So what does that really mean? Well, so the financial market is notoriously unpredictable, and a model is considered risky if it is highly dependent on a small number of features in its training set. And should the market starts to reverse trend and starts to disobey the previous trend that that this model is trained with respect to these features, our model will make a very poor prediction of the market. So that's what risk means. So again, having a better look at it, these, we have feature exposure. So basically, for this metric, we want the number to be as low as possible. So if we have a lower feature exposure, we have a lower maximum correlation between our prediction and any single feature. Our prediction is not particularly dependent on any specific feature. And in general, for this column, the lower the number, the better. And then on the third column, we have MMC, which just stands for meta model contribution. So this essentially just means how much contribution our model makes towards the prediction, the final prediction that the hedge fund uses to actually make money in the end. So basically, what the hedge fund does is that they build a meta model that looks at all of our predictions that were submitted and then make their own predictions based on our predictions. That's their meta model, and yeah, these metrics just measure how much we contribute to the meta model. So we see here our contribution to the meta model is 0, unsurprisingly, because this model came from Numerai Hedgefund. This is not original, so they have excluded us from their final decision-making process. We don't contribute anything because we didn't build our own model yet. And here we have a correlation between our model and the example predictions, which here we have 1, which obviously, because we are using the example prediction. And yeah, these are essentially the metrics that our models are assessed on. So now let's have a brief look at the example model that Numerai has provided us with, which produced the example validation predictions, so that we can leverage it to create our own models. However, this script does contain a lot of stuff that we don't necessarily need for this phase, so I'll only go over 2 parts of it that I think is most important. So the first thing that I want to go over is the set of features that this script uses to train its model. So as I have mentioned before, that the full training data set contains hundreds of different features, and it will be very hard on our laptops if we want to train our models using all of these different features. So really the solution is that Numerai has provided us with this file called features.json, and within it, it has so contained within this file are the different sets of features that we use to train our model. So within the different sets of features provided by this, provided in this JSON file, there's a set called small, which only contains around 38 different features that Numerai considers most relevant to our regression task. And this is really the minimal set of features that we can meaningfully train our model upon. And this really helps us avoid the problem associated with training our models on the full data set. But if you do have a very powerful computer at home with lots of RAM and a good CPU, perhaps even NVIDIA GPUs, you can consider looking at the advanced example model, which uses full set of features from the training data. And the second thing that I want to talk about is something that the example model does called feature neutralization. So as mentioned previously, the model is considered to be risky if it is highly dependent on a small handful of features. So the example model performs feature neutralization to really reduce the model's dependency on the 50 riskiest features in the training data set, which just really means the 50 features that the targets in the training data set is most correlated with. So this reduces the correlation of our prediction with the target, but it does make our predictions less risky. And that's really all for the example model. Besides that, it is just a very simple gradient boosted tree using the library called LightGBM. And yeah, this is the example model, and now we can move on to create our own models. Finally, I will show you some of the simple models that I have created, which you can use as a template to create your own models. The GitHub links to these models are in the description. So my models are configured in such a way that if you're working with the minimal feature set, all you have to do is to define and train your model over here between these lines. So the code before this will download the data from Numerai's server, so you don't have to download the accompanying dataset with my script. My script will do it for you, and it will read the Parquet files, read the minimal feature sets, and format the data into the desired structure. And after that, it will use your model to perform validation. And after validation, it will neutralize, perform feature neutralization. You can also tweak how many features you want to neutralize with respect to the minimal feature set. And finally, it will export your predictions as a CSV format wanted by the Numerai Hedgefund. So all of these should be taken care of if you're only working with the minimal feature set. Now, this particular model uses the LGBM library to create a gradient boosted tree. And here is another model that I have created using the Keras and TensorFlow library. That is a two-layer neural network. Again, all the code for reading the data and packaging the data, performing feature neutralization is the same. All that's different are how the model is defined over here. So again, when you create your own model using this template, working with the minimal feature set, you just define your model here and train them. And next, I guess the only thing that's left is have a look at how my simple models match up against the example predictions provided by Numerai. So after you run both of these scripts, keep in mind that it will take a few hours to run because this is machine learning we're talking about. It will take some time to train the models and make predictions. After you've run them, it should output these two CSV files, feature libraries, and I'm just going to upload them onto the diagnostic tool on Numerai's website and see how we did. Now the validation predictions of my model is just finished uploading, and let's have a look at how it fares against the example validation prediction here. Well, first let's look at the gradient boosted tree. We can see that it does better in terms of feature exposure. That means it's less dependent on any specific features. Also, it contributes better towards meta model that Numerai builds because the example validation predictions contribute anything towards the model. But our correlation doesn't do as well as the example validation prediction. That just means my model doesn't have as good at predicting power of how the financial assets are gonna, how the prices of the financial assets are going to move. Now, let's move on to our simple neural network. And immediately we can see it doesn't do as well as gradient boost tree. And from what I've been reading on the forums, in general, neural networks don't do as well as gradient boost tree or any sort of tree-based models. This is probably because of neural networks being extremely sensitive to its hyperparameters. So some of you may try to build another neural network that has a better, more well-optimized set of hyperparameters than compared to my just simple two-layer. So yeah, these are my example models. So when you're one thing to keep in mind in your when you are building your models is that you don't have to worry too much if your correlation, if your performance metrics are bad. All you have to really worry about is the risk factors, because when we combine our models, the only metric that we are optimizing for is performance. So don't really worry if your performance is bad. As long as you get above 0.01, it should be good. Just to give you a better view of what a good or what a top tier Numerai model looks like, let's go to the leaderboard. So, we're already on the leaderboard. So here we can see for the top players in this tournament, even for the top players, the correlation is just 0.04. It sits around 0.04. So I'd say for our final combined meta model, right, or something like 3, or the high 0.02s. So don't worry if your correlation is bad. Just focus on getting risk metrics to green. And yeah, this is all from me in this video. Hope you liked it and have fun building your own models.